So good morning, everyone. Yeah, please take a seat. And we have sent a couple of volunteers to round up people who are still in the hallway. Welcome. Uh, we are happy to have you here as part of the second Wyoming Computing Symposium. This year's theme will be on data analytics and computing advances for drone applications. Hope I got all of it right. Okay, thank you. So this is the second time we are hosting this symposium. So without any further delay, we'd like to invite our Vice President for Research and Economic Development, Dr. Parag Chitness, to share some opening remarks.
Great. Good morning. First of all, welcome to, if you are not from Wyoming, welcome to Wyoming and University of Wyoming. Uh, uh, President Seidel, for whom computing is at his heart, unfortunately couldn't be here, but on behalf of the university, I want to welcome you for this computing symposium. Uh, Computing is really one of the major priorities for the university, and it has been investing heavily both in expertise and capacity for actually doing the work through infrastructure improvements. We have outstanding computing infrastructure with on-site kind of computing facility called ARC, Advanced Research Computing. Now, that is has better, I think, computing power and particularly GPU chips than any of the Colorado research universities do. We have access to about 15% computer time and in NCAR, Wyoming supercomputer centers. Again, per faculty member, we have more compute time available than any of the research universities in Colorado. And I know that because the VPS or VCR at CU and we talk every 2 weeks about what are the limiting kind of instrumentation or facilities we have on our campuses. For them, is computing time and power. For us, we need more expertise. And that's one of the reasons why there are a number of new hires, including some sitting here, of really energetic, enthusiastic faculty members who use computational sciences in application as broad as archaeology, agriculture, wildlife biology, or astronomy. So from A to W, wildlife, astronomy to wildlife biology, all kinds of applications these people are trying using high performance computing and simulations, modeling, and AI. So this is an exciting time on the campus. University overall does really well and increasingly well in its research enterprise. In FY23, we had $150 million in research expenditures. So per student basis, it's similar to what CU, Iowa State University, where I used to be, or UIUC, where Gabrielle used to be, are. So our students get the same kind of research environment as they would get at any of these bigger universities. They do get more personal attention because we have only 13:1 student to faculty ratio. So it's an excellent environment. In FY24, we expect the number to increase because in FY23, we got about $120 million of grants from outside. FY24, we got $138 million of grant outside. So we are on the right path in increasing our research activities on this campus. And our emphasis on computing is part of us being very competitive in obtaining research funding. Just recently, I think, and in the audience, he laid a to a group of faculty and I think staff, like Michael, Gabriel, and Suresh, who wrote a proposal to get uh, another $3.5 million worth of computing infrastructure, $4 million worth of computing infrastructure that we will be able to install and make available during this year for our faculty and students to use. Again, we continue to keep our computing emphasis at the forefront of what is happening in the industry, which is really fast moving because of advances in AI. So this is really exciting. I want to thank, I think, School of Computing and the Department of Electrical and Engineering and Computer Science for co-sponsoring this workshop. This is, I think, the second year that this workshop is happening. The emphasis on drones and the data obtained by drones is very timely. It has applications, again, in all the sectors that are important for this state. And the type of data it generates provides ample fodder for computer scientists to use their tools and develop new algorithms to actually analyze data to make it available and understandable to general public and ultimate users. Again, this is an exciting symposium, and thank you again for coming. And I'm looking forward to what is happening. Whenever I have time, I'll drop by and listen to more talks.
I didn't want to be responsible for getting us behind the schedule. So that's why my opening remark was very brief. My name is Ramesh Sivanpillai. I'm looking for the co-chair of the programming committee. Is he here? I don't see Dr. Zhao here yet. And other members of the program committee, can you please stand up? I see Sean, I see Aisha. Yeah. And then we do have another member from Colorado State University. So I want to thank everybody in the programming committee for putting uh, countless hours and then the support from the SOC staff they provided from the back. Without that, none of this would be possible. So we still have a few minutes. Okay. Oh, we are ahead of schedule, so that's why I just want to make sure. So as Dr. Chitness mentioned, this is the second computing symposium, but previously YJISC used to host a UAV symposium. We did one in 16 and we did the second one in 18, and we are planning to do the third one in 2020, and everybody knew what happened at that time. So it's my pleasure to introduce the first keynote speaker for today uh, or for the event. So USGS has been a big uh, player in the drone world, whether it is coming in terms of introducing new platforms, testing them, sensors, calibration work. USGS has an amazing team, and we were very fortunate that in our first UAV symposium, we had Dr. Bruce Burke, who came from Resting headquarters, and they gave a talk about UAS programs in the US, and most importantly, the rules and regulations, which is always a changing landscape. Then in 2018, we had Dr. Jeff Sloan, who came and talk to us about some amazing applications, because there's something happened in Hawaii. If you all remember, a volcano went up. They came and shared all the videos they shot with UAV because it was not safe for humans to do manned aircraft. So they showed us how UAVs were used for tracking all those eruptions, and also most importantly helping the first responders get the up-to-date information on moving people out of the danger zone. So in that tradition, for our second symposium on, which is tied to UAV, it's my pleasure to invite the first keynote speaker for the event, Matt Burgess. I'm sure I'm messing up your last name. I'm sorry. Who is the director of the UAV division. As he said, he does quite a few things, and I will let him explain all of that. He is in Denver, and thanks for coming and sharing the up-to-date information on UAV applications and the rules and regulations. Thank
Good morning. I tend to be more mobile, but I'll try and stay put so you can hear me. I can project too, but I think because we have video going, they probably want me right here. So, thank you all first of all, to the committee for inviting me here today. I appreciate it very much. In the lineage of previous speakers, I worked with Bruce Quirk and with Jeff Sloan in my efforts to get here. So now that I'm here, it's great to finally have the opportunity to speak at this meeting. And obviously, to start things off, we're all waking up this morning, and to be the first speaker, I'm going to try and keep things a little bit laid back and tell you a little bit about. I think it's important to kind of introduce myself first, kind of let you know how I got to where I am as a drone professional, and then go into some of our applications, and along the way, I'll drop some tips and tricks I've learned, not only primarily for students, but for faculty as well. I've been doing drones since 2002, so I've been in this for quite some time, and it was the Wild West when I started, and we've come a long way since then. I can tell you I've heard the word no much more than I've heard the word yes. So persistence is really important, and we are here today because people were persistent, and otherwise I think we'd all be kind of stuck on the so, I'm going to, let's see here. Alrighty. So my title, it's a little ambiguous. Hobby turned into a career. Hopefully, my presentation you get a better idea when it shows the title. Okay, so how did I get into uncrewed system? I'm trying to use the word uncrewed as opposed to unmanned. We've made a switch. We're trying to be more consistent, and certainly that's the thing. So uncrewed, I'll do my. But it's been a long time coming. I think it's important to show where I started. I am the son of an ichthyologist, studies fish, world-renowned shark expert, shark attack, actually. And anytime there was a shark attack in the world, press and everyone would call our house and, hey, give us details. Well, I learned that the press, science need to try and stay separate just because it's a world. Finally, when cell phones came around, people were calling me to get in touch with my father. And I said, well, this is it. Not the scheduling assistant for him. But long story short is I spent a lot of time out in the field with my father. He was a nurse at the university teaching hospital, and so I spent a lot of time out there. I went to shark fishing tournaments, and we dissect things, and I was always collecting tadpoles, and, looking at things in microscopes, and so anyway, I grew up with a lot of science in my background. These types of symposia are nice because you get a chance to network with people. I know it's kind of a small group, so a lot of people know everybody already, but people like myself, I like to throw out some fun facts because I like to know a little bit more about the people I'm talking with. So today, I'll just do a fun fact out here. My great-grandparents were the first people to ever get in an airplane. Fun fact that 1919, outside of New York City on Long Island, Sheepshead Bay, they had an event called World Police Games every year. This big deal. Everyone came to the grandstands. There were nearly 200,000 people in the grandstands, and it was broadcast over microphones at the time. Aviation is in my blood. Lieutenant Barksdale, perhaps people have heard of Barksdale Air Force Base in Louisiana. It's named after the best man of the wedding. Anyway, aviation has been in my blood for a while. The wedding in the sky was a pretty big deal in our family just because it was a pretty big deal at the time where it was. My grandfather, so the son of my great grandparents, was also an aviator. And so when I got in touch with him and he took me under his wing and fostered my love of aviation. So you're getting a little bit of history here into the science and the aviation piece. Here's my grandfather. They had a sailboat, and we would spend our time sailing all over Long Island, up the Hudson River. I spent one summer cruising Chesapeake Bay with them. I learned all about navigation and sailing and navigation. He was a navigator. He was air traffic controller in New York City. He had me navigating our boat as if I was bringing troops into Iwo Jima. It was unbelievably accurate. And, if something was wrong, he told me to check my math. And so anyway, had a lot of love and interest, but he really fostered a lot of my upbringing in a lot of ways. Growing up, I wanted to be a pilot. He would come and we'd go walk out on tarmacs when you were allowed to do that. We'd just walk to a general aviation airport and you just walk out and take pictures. So I have stacks of printed photographs of me standing in front of all these aircraft. And at the time, it was a lot of fun and never really thought a whole lot about it, but it was shaping my mind. And anyway, we used to take that sailboat, go park off the end of Kennedy or LaGuardia and watch the planes come in for hours. And I was in heaven. I just enjoyed identifying them, much like my father. He had me identifying fine details of airplanes, just like identifying fine details of fish. So again, this is kind of how I was shaped and molded. And I promise this is going to come to drones here in just a moment. I was told pretty early that I would never be a pilot due to some medical things. And so this was pretty disheartening. And, at that point I thought, well, I'm in trouble because, this is really what I wanted to do. I spent a lot of time in grade school. My parents still give me a hard time about Lego. I would build large cities, talking about, tiptoe to get to my bed and tiptoe to go to the restroom. It was crazy, the amount of Lego I built. But again, things are interesting how it becomes part of your tapestry as you're growing up. Same with radio stuff. I had an uncle who got me a scanner radio, one of the early Radio Shack models. And before I knew it, I was listening to the local police station and fire station. And sure enough, I'd say, in about 2 minutes, there's going to be an ambulance going across the road. And sure enough, there it was. It was kind of like the navigation stuff that my grandfather taught me. It was just a lot of fun. So I had an interest in all these kind of complex and disjunct things. But looking back on it, it all kind of fed into where I am today. One final thing is that in high school, a bunch of my buddies and I got into RC car racing. This combined my radio interests with my engineering and kind of figuring things out and the Lego stuff. And anyway, hobby turned into something quite all-encompassing. I ended up getting very competitive, and I would race 10th and 12th scale cars off-road and on-road competitively. And I really never thought a whole lot about it, except that it was a lot of fun to do on the weekends and kind of took me away from, the studies and other things that I had been doing. So this, again, at the time was not all that remarkable, except it was just what I did, and it was fun. So I got out of high school and I thought, all right, well, I can't be a pilot, so what am I going to do? I'll do the next best thing in my mind, which was going to go into civil engineering, design airports. So I got excited about, finding ways to build the next, best runways and things. So I was all excited about concrete and statics and dynamics. And so I started going through the University of Florida is where I grew up. Both my parents worked at the university, so spent a lot of time there. Grew up in a college town, much like Laramie. Folks in Laramie generally, in Gainesville, it's, folks at the university or worked at a job that supported the university or actually at the university itself. So anyway, this was what I was going to do. And so I went through the first couple of years of undergraduate and really enjoyed the stuff I was doing, although I wasn't actually getting into a whole lot of classes that I saw. It was primarily weed out type classes that we all have to take, right, in order to get where we're going. I started got into Calc 2 and 3 and, differential equations, and I was going through all this, and I'm like, this is just getting ridiculous. I got so tired of writing the same darn integral over and over. And I said, there's computers that can do this for us. Why do I need to handwrite this all the time, right? And so, again, I'm not going to get on my soapbox, but it was becoming ridiculous, and I was just not enjoying what I was doing. I said, I want to get out and see the airplanes. I want to design stuff for the airplanes things. And I totally understand how important this stuff is, but there's no reason to write it all out when we've got computers that could get you the answer in no time. So anyway, enough was enough. I said, this is it. I've got to go do something that I want to do that's more exciting. And I came and I told my father, I said, you know what? I'm going to change my major. And my father saw his civil engineering son, all that retirement just went away because I was going to go to where my roots were. And my roots were outside. And I was going to transfer into the, not wildlife department, your W, from the talk earlier this morning. I was going to zoology. And so my father saw his, early retirement float out the window because his son was not going to be able to support him on a zoology degree. That being said, I was much happier. I was out in the environment. I was doing things that I enjoyed. I still liked aviation, but I was doing things to get through undergrad that I really enjoyed. And again, for students who might be here, I highly recommend you do something that you really enjoy. Don't feel like there's pressure to get you where you need to be for whatever. Enjoy what you're doing. Now, granted, you might have to take some integrals along the way, and it's not all that fun, but there is light at the end of the tunnel. So I got my undergrad in zoology, the final year of which I worked with a professor in the zoology department who it was kind of an interesting situation. It was a husband-wife team. One studied primates and the other studied fish. And I knew the fish person through my father and through the university, the primate through my undergraduate degree. I worked in their lab as a volunteer to start. And then I got hired on some soft money, and that was a real good start for me. Long story short, it took me to Uganda, Central Eastern Africa, with them, where they run a project called the Kabali Fish and Monkey Project. And so I ran around in the rainforest studying what monkeys were eating and not eating, and trying to figure out why they were eating and not eating certain things, and worked with air-breathing fishes in the swamps, papyrus swamps and things. It was a great experience for me. But there were times during that trip where I was thinking there's got to be better ways than the manual types of things we were doing out there, whether it was geopositioning. We had a military GPS that had a self-destruct button for those who are old enough to know what I'm talking about. The military-based GPS systems were, highly accurate, but they couldn't get in the wrong hands. This was kind of where we were. They were having me pace off the circumference of a lake, and there's got to be better ways to do this. I'm a technology guy, so come on, this is driving me crazy. And there were lots of opportunities to use crewed aircraft to take images or look at functional groups of plants and things besides just walking transects, phenology transects on the ground. And so again, I was just seeing all these opportunities to use technology, and I think that's what kind of brings us all here today is the use of technology. After that soft money dried up, I got my first job working for the USGS, and that got my foot in the door with the federal employment system. And that's a hurdle amongst itself. It's kind of like getting your first academic job. It can be a bit of a challenge. Same with federal employment. I was a fisheries biologist. I did work in Florida freshwater streams. And so I would work in freshwater and I would play in saltwater. So that was kind of, again, growing up in Florida, that's kind of how I did work. I did a lot of electroshocking and things. And this is where I really got my start on drones. For part of my master's, came up out of this position out of USGS. I decided to go back and get a master's. And we would float the river on the boat. And I was taking pictures along the shore as the boat would drift down in order to stitch them together to estimate how much vegetation was going to be inundated as the river levels would rise and fall, and how this tied into the ecology of the critters, the things that were there. It just became completely obvious to me that it would be so much easier if I could just fly right down the river and take these pictures, and it'd be done in so much quicker time and all this. And it was, at the time, graduate student, I didn't have any money. I was having a hard time finding just the money to do the project I had hoped to do. Getting a crewed aircraft to come fly this remote part of the Florida Panhandle was just out of the cards. So I started flying RC airplanes because I knew RC stuff. And so I went to the local flying field and I started flying. And I picked it up very quickly because I already knew how to do RC things, and flying just came natural to me. And so, hey, this is pretty cool. GoPro had just come out, and their first Hero Air. And so I said, what if I just tape this thing to the bottom of my RC airplane? So that's what I did. And I went and flew at another graduate student had a family member who had a large cattle ranch for dairy cattle. And I took my RC plane out, and they knew how many cattle were in their pen. I'm not an agriculture person by trade, so if I offend anybody, I apologize. But there were no number of critters in a pen. And I took my RC airplane with the camera firing every couple seconds and tried to figure out how many I saw from the air. Well, that's what got me going. And so at that point, I was hooked. I said, there's a future in this. And I said, as a scientist by training, and I had a master's degree, I said, for PhD, I want to get this technology in more scientists' hands. And so I went to our wildlife department at the university and I said, hey, this is kind of out there, but is there a professor here who might take a chance on me? And let's try using drones for science. And I found a professor, Dr. Franklin Percival, who was at the University of Florida, now retired, was an alligator biologist. And he said, let's give it a try. He had some applications for using basically drone surveys at the time. And so he was a visionary. At the time, also, he was actually coming off some kind of tough time in the fact that his son had died in a helicopter accident not too long before that, doing aerial surveying. So this actually hit him pretty hard, as here's an opportunity to get some people to stay on the ground, yet still collect data. I didn't know that at the time, but after the fact, he confided in me, and sure enough, that hit home. University of Florida, we didn't have a drone program by any means. I was the drone program, but I quickly needed to get a committee together, and so I went to the aerospace department. I said, hey, is there somebody here who wants to help build some airplanes? And sure enough, I had several folks who were interested. I went to the geomatics department. I said, hey, I need some help with geopositioning. Not only do I want to take pretty pictures, I want to know where they are on the earth so I can quantify my data. So I had some folks from the geomatics department. Obviously, the wildlife department. I had lots of different professors who had applications to use drone survey. So getting a committee together wasn't that hard. Getting a committee together in the same room to reach a steady, objective, that was hard. I quickly became a program manager for my own dissertation, but I also quickly became the go-to drone guy for not only the university, but for the whole Southeast. And I had the university lawyers contacting me and things, and whoa, I'm just a grad student here. I'm trying to get my PhD done. And I had people way above my level asking me about drone regulation and law. And I'm just trying to get the technology going. Let's find a law student who wants to take on the law. Again, it was a different time, but this is where we were going. And so we ended up building our own aircraft. This is before NDAA was a big deal and blue drones and all these things. It was still quite the Wild West. I will say that my very first conference I went to, drone conference, was in New Mexico. It was 95-ish% military. I came in there, graduate student, going to tell you about flying over cows. The place just emptied out. That nobody cared. They didn't want, they were military. They were shooting things down. They were, they didn't want to hear what some biologist student wanted to tell you about flying drones. FAA, they got up out of there. They're like, oh, drones will never be in the airspace. We have enough problems with with crewed aircraft. That's what I was told. Oh, there's no way you guys will ever be flying this stuff. This is just ridiculous. So there I was. I gave talk to about, I don't know, a handful of people. One thing that really stood out from that conference, however, somebody came up to me after my talk and said, when you can fly a LiDAR on a drone, you call me. I wish I had written that guy's name down and number because, gosh darn it, we're doing that all the time now. But at the time, that was like the pinnacle of what he was envisioning. I ran the UF drone program while getting a PhD for over 10 years. And we came a long way. We rotated a tremendous number of students, whether it's building aircraft or payloads or developing some of the first geopositioning algorithms to work with timing and shutter exposures and things. It was great. I was learning all this stuff. I was also integrating with the U.S. Army Corps of Engineers, who was funding most of this research. And again, I learned very quickly that as a program manager, or I learned very quickly how to be a program manager, how to keep the funding people happy, how to keep my committee happy, how to keep the students happy. Hey, have you ever tried to take 3 aerospace engineers out into the field where there's spiders, it rains, there's no internet? They learn real quick that wildlife biologists are built differently. No, it was great because I learned how to handle people, right? How do I get all these different mentalities? And everyone was still striving for the main goal, which was to build aircraft to fly these things. At the same time, I was battling with FAA. And so things have come a long way. Let's just put it that way. I spent time, again, this is all out of North Central Florida. I was at FAA in Atlanta to the Southeast group. I was trying to get permission to fly in the Everglades. I just wanted to fly way out in the middle of nowhere in the Everglades at a low altitude, but it was within 30 miles of Miami International Airport. And I was told if I didn't have a Mode C transponder on my drone, I was not allowed to fly there. The smallest Mode C transponder at the time was the size of a shoebox and weighed 20 pounds. You can't fly 20 pounds on a 6-pound aircraft. I told FAA that if the airplane's down where I am, I'm going to be picking up bodies out of the water. These people don't need to worry about what I'm doing. If they didn't want to budge, I continued to push. Eventually, I was able to get in there and fly. It's things like this where, again, there was a lot of no along the way, but you got to push at the right time and push the right people to get to where you want to be. I may have one of the jobs in the federal government. It hasn't been an easy job. And I think all of this point is to really just let folks know that the journey from where you start to where you want to be is very rarely a straight line. And I think almost everybody in here can attest to that. But especially for students, I remind them of this often, is keep what you want to do, as the goal, but just know that you don't always get there straight from point A to point B. So I was running around in the rainforest in Uganda. I was, doing all kinds of odd jobs to get where I am. But now I'm doing what I really love, and that is applying drones and science, getting low altitude aerial imagery and other sensors up over targets and, pushing things forward, doing it safer, doing it generally cheaper, and certainly a lot faster. And, I feel very fortunate. Okay, so that's a long story about me, but I just wanted to give you a picture and just think about that yourself. I'm going to tell you a little bit about where I work for folks who aren't familiar. I work for the U.S. Geological Survey. They pay my salary. However, my office in Denver, the National Uncrewed Systems Office, is basically the R&D, the T&E, the test and evaluation, the research and development branch of the entire Department of the Interior for drones. So we've been doing this for a very long time. My office was built in 2008. That's when it came together, was officially recognized. At the time it was the Unmanned Systems Office. We're now the Uncrewed Systems Office. And so anytime any of these groups want to start something with drones or try something new with drones, basically comes through our office. So I've got my finger on the pulse of not only what USGS scientists are doing, but also what law enforcement's doing for parks, the Parks Department. And the Fish and Wildlife Service has law enforcement as well. I'm not a law enforcement professional, but I certainly appreciate that. I help bring drones to law enforcement in the state of Florida. I also am working with folks who are doing stuff with dams. And again, so my civil engineering background, I love that stuff. I love seeing what people are doing. I love seeing drones being used for these types of applications. One of the best parts of my job is I get to think outside the box and talk with people who have dreams of using certain sensors, and I'm trying to find ways to get those sensors over targets with drones. Our office has basically 6 major things down here at the bottom. Our objectives. We have a mission statement and a goal. I think everybody pretty much has one of those, but these are our tasks. We train operators on how to use uncrewed systems. So folks go out, they get their Part 107 now, which is basically your flying license. You don't have to pick up a stick to go fly and get your license. It's a written test. You don't have to fly anything and you can have a license. We take that and teach you how to fly, basic stuff, and agree at a certain point, you're qualified to fly a drone for the Department of the Interior. We develop the qualifications for that. So again, as new drones come out and they are either more or less complicated, we make sure that the folks who are being certified to fly that aircraft are indeed capable of doing so. We develop new data collection techniques. So, a new sensor to us comes on board. We go fly it. We, have a look at the data and things, and then we come up with ways to make it more efficient. And so we come up with best practices. We don't want to see scientists go out there for the first time and be like, I wonder how to fly this. And come back and there's big holes in the data. We want to be able to say, here's how you do this, design some transects here, or go up, do a circle, come back and land. Let's look to figure out where the things are in relation to where you are, stuff like that. We do a lot of aircraft testing and sensor integration. So as probably most of you are aware, there's a big push, especially within the federal government, to go to U.S.-made equipment, and I'm all for that. Trust me, I'd love to keep all the money right here in the States and support local business. The reality is that's just not achievable in the very short term. We are trying our best to get as much of that done. The reality is, if you've been in drones long enough, you know that the adversarial countries have been doing this for years and have just found out ways to make it work. And it just works pretty much every time. So while if I had my choice, everything would be blue drones right now or US made. The reality is we can't pump it out as fast as countries are doing it overseas and a lot of things. So we're moving over to new aircraft now, and we do a lot of sensor testing. We do proof of concept missions. So if the Park Service comes to us and says, hey, we need to go fly the Statue of Liberty. We want to make sure that the corrosion on it is still safe to send people to the top. We don't want the Park Service to send their rookie green team to go fly that. That's too high of a, the spotlight will be on that crew. If there was any problem, it could look really bad for the entire interior and for the drone world for that matter. So any sorts of sensitive things or high focal value, our office is generally, because we're flying all the time and we have a lot of experience on doing these things. We do a lot of sensor calibration, accuracy assessments. Not only do we want to collect pretty pictures, we want to know where the pictures are on the Earth, and we want to be able to put that USGS stamp of approval, say this data is accurate. And so that's a big part of what we do. And then in relation to this symposia, that we do a lot of data processing and archiving of the data as well. Talked briefly about some of the platforms we've been using up until recently. A lot of these aircraft are old. They don't produce them anymore. We're able to fly a lot of these until they no longer fly. We can't buy any more parts or pieces, batteries for any of these things. So as you can see, we had a lot of 3DR solos. That was kind of like our F-150, did a lot of things well. We could put a lot of different small sensors on there, but replacing that fleet of 114 aircraft is pretty tough challenge now. We're moving towards these blue drones. Rather than have everybody in interior, any pilot in interior, go out and try a drone that they've heard about, been told it's going to be their answer. Our office goes out and gets one of them and becomes the clearinghouse to find out whether it's worth a darn. Rather us spend the money on one or two aircraft and put them through the paces than to have you guys, our scientists or our users save their pennies for 2 years and buy I'm not going to make a mention. Some of these are better than others, okay? Some of them will do what you want. Some of them will tell you, everyone will tell you they'll do what you want, but none of them are going to answer everything. I think one of the take-homes, if you don't take much from my talk this morning, is that just know that one drone is not the answer to everything, okay? There's much like your automobile. A Yugo will only go so far. Sometimes you need an F-350. You've got to get something. So again, there's a lot of things here. We have, in our office, have put all these, we have a standard test that we put these things through, whether it's mapping or flying in terrain. We fly at temperature, so we're flying in really cold weather. We take it to the really hot weather. How well do these things perform in those things? How do they perform at elevation, 12,000 feet? How do they perform at sea level? Can you start them on a boat that's rocking? Things that most of the manufacturers don't have answers to, but these are the things that scientists and users within the interior are doing. Okay, so that's a little bit about airframes. Sensors. Most of you are familiar with the electromagnetic spectrum. Our eyes can see a very small piece of that puzzle. Our goal, well, wasn't in the 6 dots that of our objectives, but one of our hidden objectives is to try and get UAS sensors that cover the entire spectrum. Things that will do UHF or VHF radio tags all the way to gamma rays, radiation. So my goal is to try and go out and find those sensors, and because it won't be long, if someone's not doing it now, somebody will come, Matt, I need to find radiation. Okay, let's go find a gamma ray sensor that works for you. So there's a lot of different categories, right? And that spectrum is quite large. In the last, say, 6 years, we spent a lot of time working on LiDAR, and I'll show something on that in just a second. Multispectral, hyperspectral. We've got magnetometers in our shop now. We've tested ground penetrating radars, gas sensors. What do I have here? Oh, there's your gamma ray spectrometer, radiation. We're doing all kinds of things, and nothing is off limits. Right now, the things that limit us are finding an aircraft that is approved for us to fly, that's either big enough or small enough to get where we need to be, and finding battery sources that will allow us to fly for more than 3 minutes and have to land and change batteries. There's a lot of different things, but again, we are, I don't have RGB, so regular optical imagery, we've kind of quote unquote perfected that, but we're also working on that as well. LiDAR. So much like aircraft, sensor companies will tell you that their sensor can solve the world's problems. And they will tell you this because they're a business. They're trying to make money. And quite frankly, the reality is not all sensors are the same. And it's really important to get a sensor in your hand and put it through to find out what it can and can't do. We have worked with YellowScan, who's an integrator, so it's got a lot of different parts. They integrate the GPS and IMU unit with the actual laser head and develop software to make it all work. Each of these has different laser units and GPS INS units. We work with that company just because it provides us a standard to work with. We're not partial to them for any other reason. It's just they integrate a lot of different things, and we like that, and they're receptive to us working with them. If you need to go look to see, gentle undulations of the fields, just west of here, I can put you in the right LiDAR unit. If you need to know the land has moved, the dust level moved this much, then I'm going to pick a different LiDAR system for you. I spend a lot of time working with the principal investigators, the PIs, and ask them, what do you really need? Oh, Matt, I need LiDAR. Maybe they do. Let's talk about what you really need. And you may talk with them for about 5-10 minutes and realize photogrammetry may be much easier to collect and will actually provide a better result for what you're doing. It's important to talk with folks and get into the crux of what the data source, whether that's in computers or drones or both. It's important. We need to find out what is it that you need, and to what resolution or accuracy do you need? Do you need to know that thin layers have been removed, or do you just need to know, yep, it's subsided, it's gone down a foot? That's going to help us determine what we're doing. Multispectral. I'm sure there's some agriculture stuff here. Obviously, with Wyoming, that's a big deal. Looking at multispectral imagery is very important for finding things with crop health, and to know where you need to add water, or there's too much water. Maybe you need to add nitrogen, or the fertilizer load is too high at a certain time of year. Multispectral is a really great tool for that. Obviously, we have satellite data that's providing some multispectral. We want to make sure that the drone-based multispectral units are worth a darn. And we want to make sure that when you buy a specific sensor, how good between sensors of the same model, how is their production good enough, or is they just putting them together quick and sending them out the door? So if I get a MicaSense Altum, for example, is your Altum going to be appreciably different than my Altum? So a lot of work is being done there. We're really keen on finding multispectral companies that are producing products that match up with satellite-based information, so that we can have multiple scales of data. And I think scaling is a huge part, whether you're in computers or drones. Scaling is an important piece of the puzzle. Hyperspectral. So we talked about RGB. You've got three bands, R, G, and B. Multispectral, you might have 10 or 11 bands. Hyperspectral, you've got hundreds of bands. And so hyperspectral, again, provides a tremendous amount of information. It creates data sets that are tremendously bigger than any of the things we just talked about. Cracking this nut is not easy. And until recently, most of the hyperspectral sensors were too big to fit on any sort of 55-pound or less drones. We're finally getting a few companies who are producing some things. I will tell you that the optics on these things are actually very good. They're quite impressive. The geopositioning piece of the puzzle is lacking. Most of these photonics companies who make these things, they don't know anything about geopositioning. So we're working with them to try and help get good imagery, good data, but being able to apply it on the Earth as, true data. Let's see, how am I doing here? Cool. Get going. All right, so gamma ray spectrometry, Department of Energy, drones have been used for dull, dangerous, and dirty jobs. There was the 3Ds when I was, showing my age, but the reality is going into radiation areas is dangerous. And so people don't want to have to suit up to go do these things. Why not just send a drone in with a sensor and generate these heat maps to help us identify where these are? Not too far from here, or from where I am in Grand Junction Airport in Colorado, DOE has a facility where they can take their crewed aircraft with these radiation sensors and roll them over these calibration pads that have known concentrations of these radioactive materials. And so that's how they calibrate their crewed aircraft. I said, well, this is a great opportunity. Why don't we just take our drones there and see if these sensors are worth a darn? Oh, you can't do that. That's FAA. That's an active airport. The National Guard flies there. You guys can't do that. I think we can. So again, talking to the right people, going to FAA, say, hey, look, we can operate just like everybody else. We'll announce when we're taking off. We'll talk to the tower. We'll stay, off the active runway. We'll work this. Let's give it a try. Sure enough, we've got permission to do so. It's a great opportunity for us to go test our equipment. Also to show, hey, look, drones can work with the existing airspace. Hey, look, F-18s flew in. No one was expecting them. It's okay. We were ready. Everything was fine. It's things like this that it's just important to show. Again, generating heat maps. Most of these sensors were designed to be walked through the forest. Putting them on a drone provides a whole bunch of different elements that they weren't necessarily designed for. So we're working through to try and come up with ways to make these things work better. We'll go through a couple projects. The previous edition of this conference, my predecessor showed a whole bunch of examples, including the Kilauea. I'm not going to focus on Kilauea just because I think there's a lot of other cool things that we do as well. We worked with the Bureau of Land Management and NEON, the National Ecological Observation Network, part of NSF. They have a crewed platform that flies hyperspectral, LiDAR, RGB over all these parts of the U.S. And so we just have timed some of our opportunities to fly drones as they're flying overhead to compare their sensors with ours. And so it's been a great opportunity for us to look with some professors, some PIs and some professors both, to look at carbon sequestration and things on these public lands. Let's see here. I talked about calibration and validation. Big part of what we do is working with our CalVal team. USGS Aeros in South Dakota, those folks are who acquire our Landsat imagery. And in order to put that out for public use, somebody's got to calibrate and validate it. Make sure it's worth a darn, because you don't know who's going to use it as an end product, but they could be using it to make very important decisions. So we went out with their CalVal team and flew our drones as the satellites were passing over, had a bunch of calibration panels, and again, great opportunity for us to make sure that our data is within spec of what we would put the USGS seal of approval on. Scanning for bridges. Again, stepping outside of my environmental hat, taking my wildlife hat on, and putting my engineer hat on. Using drones now with increased AI and ML capabilities allows us to put drones in places they historically weren't safely before. Let's just put it that way. Doing bridge inspections now is really a great tool for drones that have collision avoidance and also know where they're missing imagery. And so the ability to say, go get underneath this bridge structure and photograph it to completeness. Again, before ML and AI stuff, this was really a challenge. I can tell you that I may have crashed a few drones underneath the superstructures of bridges. Guy wires, kind of a nemesis to aircraft. These things are becoming less of an issue, and that's great for folks who are not quite as skilled, haven't had the experiences that some of us have. So again, great use of technology. We're starting to see more and more adoption, not only across the federal government, but in state governments and others as well. Earlier this year, I was in southern Texas, south of Brownsville. It was, let's just say it was hot. We took some of our drones out there to look at this Texas tortoise who's endangered. Its habitat is being developed into houses very quickly. We needed to go out there and take some of our newer aircraft and give them a shot on some of these projects, because our existing aircraft fleet will be grounded permanently at 2025, the end of 2025. So after that date, all our existing Chinese and other aircraft will all be crushed to bits. So we need to have some aircraft in hand. So we want to get these things out. We're having good success with some of these, others not so much. If you want to come talk to me offline, I will tell you the kinds of things we're finding. I'm not going to shoot any of these companies down. Another use of one of these newer technologies, we used a Skydio X10 very successfully to map this 352-foot obelisk structure in the middle of Lake Erie. I don't know if folks are familiar with Perry's Victory Memorial, but it stands like a statue out in the middle of the lake, and it's starting to deteriorate. And there's an elevator system that runs up the middle. It's a little bit rickety. You got to pull the curtains closed, and it makes all these creaks and things. Well, I got to the top and I didn't fall, but let's just say that they're concerned about it falling. And so in order to get cherry pickers and other things out there to do these sorts of inspections, it was going to be very costly. We went out there, and in one day, literally one day, we were able to map that whole thing. I think we had 4,800 images. But again, one day's worth of work. The place, we shut off half of it. So people who were coming to the site to see it could come up and touch the base and everything. We were working on the other half of this. And so again, the park liked it because they were getting data and the people were still able to come see what they had come to see. Okay, shifting gears. That's just a quick thing, and I appreciate your patience here, but what happens after we collect data? That's kind of the crux of the symposium, right? Let's talk about data production and data processing and things. So we collect data. In the field, first thing we do is we look at the raw data. We just want to make sure that the images are clear. If it's an image, a full image sensor, we want to make sure if it's LiDAR, we don't have swaths that are missing. We want to make sure the overlap looks good. We just do a real cursory look. You don't want to come back after being a week in the field and realize, oh, there's a big hole in the data. We back up the data. So we go out of the field, we get to the hotel room, and we back up the data. So anything that's on cards or on flash, we copy onto our data drive, not the operating system drive. I don't know why I have to say that, but I do. Actually, I do know why. Again, things like this really just help scientists who are not necessarily computer experts. Things help with it. I'm not a computer expert. You all are, but I do know the reason why. I also will get an external drive and put it there. I want to have multiple copies of the data because, quite frankly, the flying is the sexy part. The data is what puts me out in the field in the first place. So that's what's all about. I get back to Denver, whenever that might be. First thing I do is I take those drives and I copy everything up to our file server. And this is a computing conference, so I felt obliged to put some information about our infrastructure for those folks who are interested. There it is. So we've got all the raw data copied up and it's being backed up. We start post-processing efforts. That often involves proprietary software that the sensor company will provide you. it's not really fair to expect our PIs to understand the inner workings of this type of stuff. So our office tends to do that and get the data into a format that we've talked with the PI about ahead of time. So they need LiDAR data, we'll get them a LAS file or something of this nature, rather than have them try and figure out all the details. We integrate any survey data. So again, I'm not a professional surveyor. I work for the U.S. Geological Survey, but I work with a lot of professional surveyors. I've learned a tremendous amount, both through my schooling as well as in the real world, about doing surveys. It's really important if you want your imagery, your data to match up with what's on the earth to do surveying stuff. We try and do that in our office. Again, not expecting the PI to have all that expertise. We try and do that part of the, whether it's trajectory, corrections and things, we do that in our office as well. Okay, then we use several paid software titles, several freeware, other things. I don't want to promote specific companies, but if you come talk to me after, I'll tell you more about those types of software. And we get them into a format that the PI can then take and use. The last step that's probably the hardest for everybody in our office is composing the metadata, which is so critically important for folks to pick up the data sometime down the line, but to know how it was collected, how it was processed, and all of this. Again, we do that in our office, again, expecting the PI to know what the aircraft was, how fast we were going, all of this stuff. That gets done. And then we get to hand off the data and any data products we may have done to the PI, and then they get to run with it and massage it, and quite frankly, they get to do the publishing. Now, coming out of academia, publishing, I know how critical that is. And I grew up in academia and I saw how critical it was. And I enjoyed publishing. In my current job, I don't get to publish. I don't have the bandwidth to do so. I would love to publish every project I've worked on. I can't. So that's a trade-off for doing the kind of job that I'm out in the field a lot. I'm testing new sensors. I don't get the opportunity to write as much as I'd like to and to get the information out. We're working on that. Quite frankly, our office needs more bodies, so we'll see what we can do on that. Okay, data. Data products get paired. So at USGS, we have official data release, and that provides a digital object identifier, a DOI number, which I think a lot of you are familiar with. That allows our data to be indexed and cataloged and sort of, so this is a critical piece of the puzzle. Our office will do that, or the PI often will do that. Again, we're part of this process. And then where does the data go after that? We obviously keep a local copy on drives of, backup for historical purposes. But then because we're the federal government, all this data generally becomes freely available. And so it gets copied to our AROS data center, and then often appears on either the Science-Based Catalog or Earth Explorer. Those are our two primary methods. That's where you get your Landsat data and these sorts of things as well. Again, talk to me over a beer. I'll tell you more thoughts on these catalogs, but again, it could use some help. How long does it take to go from data to products? Get that question all the time. That's a critical piece of why we're here at this symposium. It depends. I wish I had a nice defined answer for you, but it really depends. How accurate do you need to be? Do I need to let my geopositioning data marinate for 2 weeks so we can get the ephemeris just right to know where things are on the Earth? If you just need to know quickly, there's a fire over there, I can get you that information quickly. But if you need to know the actual perimeter and whether it's moved in the last 10 minutes, that can take some time. I put together a couple ideas, right? This is not set in stone, but typical small photogrammetry projects within an hour or so, I can have something for you quickly to do whatever. If you've got really large projects like that obelisk Perry Victory Memorial, it took a couple days to generate those products. Granted, things have come a long way since we started, but again, here's some ideas of projects and types of things we get. This is actually, I don't have any scale on this, but this is a very large, multi-mile photogrammetry project I've been working on. Up until this point, I've only been able to stitch sections together. Finally have some HPC ability. I can't wait to throw all this stuff in there and send it on its way. Let's talk about that some more in a minute. How long does it take? Here's some things that I think are really worth talking about. Technology is really improving. When I started doing stuff back at the university, I used to take a big old tower computer full of graphics processors, and I'd carry that up the hotel room, plug it in, and start processing at night. I needed something, but the little laptops they gave us in grad school or we purchased, they just couldn't handle it. And so we've come a long way with that. So I'm very thankful to folks coming out of academia with computer science degrees and who are help pushing this technology forward. Stuff like this is making my job, capable of being done. Again, these are some generalities, but software is much more prolific. There used to be a couple titles that we would use, and getting a license for it was challenging and blah, blah, blah. Obviously, open source stuff has helped move some of that along. There's more functionality, especially for us dumb wildlife society. We don't know how to do this computing stuff. It's great that there are people who are, and they're generating GUIs that make it easier for us to do the work. High performance computing. Obviously, this is a game changer. Data sorts that were historically too large are being processed. Lowly old me can get onto an HPC finally. Getting that even 6 years ago was tough for me, even in my federal position. Now I have the ability to do so. And now I'm getting the results a heck of a lot faster. And that's critical for everything in the world. Everyone wants information yesterday. So artificial intelligence, ML, I hit on that a little bit. It's training data sets used to be a real pain in the neck. Now it's so much easier. Things continue along this trajectory. And again, I think this is a great discussion for this symposia. I hope to learn some more from folks who are active in these environments. What are some of the societal impacts of using uncrewed systems? Whoops. I just hit on some of the major ones that I think of day to day. There's obviously a tremendously longer list of these things, but obviously commercial applications, you're talking about drone delivery, it's a big deal. Precision agriculture, a huge opportunity to minimize environmental effects of broad scale spraying of pesticides and fertilizers. Urban air mobility. Pretty soon you're going to be moving between Laramie and Denver on a uncrewed aircraft that's going to fly 4 people right here, and it's coming. I'm telling you, it's a big deal. United just put a tremendous amount of money into one specific urban mobility company to develop the next UAS that's going to transport people. Public safety, there might be some public safety folks in the room. It's transforming the way public safety is being done. Still need the people, bodies on the ground and people to talk sense into people. But the reality is recreating crash scenes and doing crowd inspections. It's really ideal. Surveillance and security, I talked about earlier. Military, I've kept my hand on the pulse of what's going on in the military, but I'm really focusing on the commercial and the non-military side of things. I think it's great what the military is doing. A lot of technology has come out of the military, finally gets into our hands and we can use it. But there's a tremendous amount of stuff going on there. Environmental, I just hit on a bunch of that. Infrastructure, we talked about that. Media and entertainment. The movie industry, I can't tell you how many, I spend time watching the movie, but I'm really watching to see which images were done with a drone because that's the way my brain works. CNN, Matt, you're the drone guy. We're in Atlanta. We want to have a drone for media. Okay, let's talk about it. So help get them into a drone. All these things are all important. Talk about the job creation. Again, blue drones, the idea is to get more money back into the US economy, all for that. And so again, it's been big. Regulatory, I told you some stories about FAA. FAA and I get along great. We just have to sometimes work through some issues. This is the crew I work with. There's 7 of us. 6 of us are pilots. 4 of us fly often. And you can see it's a diverse group. We've got folks who focus on IT. We've got folks who focus on calibration. We've got a LiDAR expert. We've got a lot of different pieces, but we all kind of fill a niche. And we could use some more help. And so we're trying to get some more funding to hire a few more people just because we don't have the bandwidth to do everything that we're being asked to do. So, can you turn a hobby into a career? In my case, I think you can. And with that, if there's some time, it looks like we've got a little bit. I'll take any questions you might have. Wow. I appreciate everybody's attention. I know that was a lot.
I can ask you a question. Can folks hear me? Back? Okay. You mentioned about not having enough people. So what about some internship opportunities for students? What kind of things exist and how can they get to know them?
Perfect. That's a great question. I'm going to go back a slide. Try to. This is our website. It's not well maintained. We could use some computer help up there. Keep that in mind. uas.usgs.gov. Go there if you get a chance. That'll show you some more stuff that I can't show you in this short project. But following us on Twitter and Instagram also will provide some other insights and kinds of things that we're doing. And we do, I think, 3 posts a week. So it's pretty active. All of this goes back to, if you have questions, you can contact our group at uas@usgs.gov. And that goes to all 7 of us, and we divide and conquer. But that's, if you got hey, I saw your talk at the Wyoming, and I'd like to talk more about this, you can email me directly, or you can just go to uas@usgs.gov. That's how I would recommend people get in touch with us. As far as internships, the federal government gets really hairy, and that's just the best way to put it. I would love to have interns 24/7, 365. There's some pitfalls in the HR department, let's just put it that way. Please just reach out to me, okay? And I will try and get this. The answer to your question is there are opportunities. Getting you directly to where you need to be is not direct, okay? And I can work with you to help that. But yes, we need some help, especially with computing and resources and data processing. We spend a lot of time, we collect a lot of data. It needs to be processed. Yeah, good. Outstanding question. And you hit right at my heart because, again, working at an academic, that's what got me where I am. And I totally recognize the importance of working with academics because I wouldn't be here without it, right? The reality is, so again, reach out to us. That's honestly, we don't have a list of things to do that doesn't come from Reston and say, hey, you guys need to go do this, that, and this. We get people reaching out to us at uas@usgs.gov from industry, from academia, all these groups say, hey, I'm a professor in computer science and we've got HPC and we would love to get 3 of your largest data sets to run through and look at the model. That's exactly what I look for in my email. We get a lot of email, and trust me, we may not respond in the first 24 hours, but we're all reading it. We're getting to it. Again, the bandwidth, there's 7 of us. The reality of this is please reach out to us. We love cooperating with these folks. It only helps us help you, and you help us. It works both ways. So let's do that. Yeah, go ahead.
Is there a reason you're limiting yourself to non-exemption letters?
Yes. Here's the deal. Each of the 11 bureaus you saw under DOI can interpret the rules up to a certain point on their own. There's an Office of Aviation Services located in Boise for all DOI aviation. That's crewed and uncrewed. We are told by them, here's the aircraft you can purchase. Okay, and that is beyond my pay grade. I make a lot of suggestions, but I get the word no a lot. Again, I have an exemption to allow me to try things that are not necessarily blue or NDAA compliant. But the reason is, for the most part, most of those bureaus are going to stick to the letter of the law, and that is being told it must be blue, it must be NDAA compliant. The level at which it meets NDAA compliance, at what point does a resistor in a gimbal become prohibited? That's beyond my pay grade. My job is to say, hey, look, here's a drone. It's a blue drone. The sensor, all that, that's what's really surprising to me. The sensor, nobody in the government cares what kind of sensor. I could put Chinese flag on the side of a sensor. And I mean, it wouldn't be good for PR, but the reality is this is people who are not necessarily as educated as we are. And again, I'm one voice, right? And I'd love to be everywhere at once to try and set the record straight, but it's complicated. And I would love to talk more about that. Again, that's several beers worth of talking. Yeah. I'm sorry.
It was about kind of the geospatial response there. And part of the presentation was talking about how they utilize drones in that response. So I guess it's NOAA, right?
Yes. Commerce, correct. Yep. It's okay.
And then working with our engineers,
Defense.
and it was interesting how quickly they talked about how they brought in bigger drones. And because, you know, the person that was in charge of the command center had sort of the ability to pull the lever on that and bring those in. And so I think sort of having the conversation and even across between Interior and Commerce and other groups, like how do we sort of come up with a strategy to move forward? Think about that. I don't know your thoughts.
No, I do have thoughts. In fact, it's particularly salient because this time last week, I was in Albuquerque. Every year I lead a federal UXX workshop, and it's very similar to this. It's got a few more people, but the reality is it's groups, anybody federal agency who has UXS, any sort of uncrewed systems is invited. And we talk about these things exactly. So I had folks from Army Corps, I had peace from NOAA, I had commerce, I had energy, I had folks from all these, and they provide, you know, a 15-minute talk. And then the work actually happens over dinner, over drinks after, and we talk about these things. And that's the reality. And so that collaboration, that communication piece is so critical. And yes, the Department of Defense has a tremendous number of waiver options, and they can use a lot of Chinese stuff right now. And the Congress folks, no offense to the Congress folks who set these rules down, they turn a blind eye to the fact that some groups can use things and some groups can't. And again, I'm frustrated by it, but I also know that that's a battle I can't win myself. So again, communication is so critical. I'm just a very small piece of the pie, but I'm trying to be a loud voice for all of the communities that are out there. Nope. We have time.
So we have to take a short break, but before that, it's my pleasure to introduce the director of the School of Computing, Dr. Allen. Come on in, and please.
Just want to say thank you to Matt and pass on a few goodies to remember Wyoming for. And Lorna has other goodies outside, so if people want to pick up some swag, I think there's a desk. Right? Thank you.
Well, thank you very much. I appreciate it. Yes.
Thank you.
Thank you very much. I'll be around for the remainder of the conference, so please just find me at any time, and I'd love to talk drones, talk airplanes, talk Lego, whatever. Thank you.
Thank you, Matt. And we'll take a short break. I think when we come back at 9:30, we will have Sean Field. Please have a seat, and we are ready to go to the next section, which will be a lightning talk, a series of talks. And this program is evolving, but I just wanted to let students know who are here and those who are looking for extra credit opportunity. We do have sign-up sheets. So if you are in my class, we got a sign-up sheet here and a person there with the sign-up. Please enter your name to let us know you came. And now we have a newly appointed session moderator, Dr. Ramesh, who will run the session on lightning talks.
I'm normally loud. I don't need to use microphone, but just to be cautious. But we have lightning talks, which we hope to take 5 minutes each talk. And then after each talk, I'm going to take questions from the audience, hopefully. And we will start with Dr. Field, Sean, that I call him, but you guys call him Dr. Field, I guess. So,
Yeah, thank you all for sticking around. So I'm Sean Field. I'm assistant professor here in the School of Computing in the Department of Anthropology. I'm going to be talking a little bit about projects that I've been working on that I call Archaeosite, which is kind of also flippantly referred to as an everything bagel approach for UAS applications in archaeology. For those who don't know what archaeology is, pretty straightforward. It's the study of past people through material culture. The big problem, because materials don't exist in archaeology, is that we have an incomplete record, right? So machine learning, image classification, drones, remote sensing are all kind of really good solutions for that kind of existential problem in archaeology. So this project is a way to kind of bring those things together to hopefully get better data for archaeology. So what the real objective is that in the future, we should be able to fly really high quality drones and then in real time or after the fact, be able to collect data that allows us to identify and detect archaeological resources at multiple scales. So in this, I'm going to kind of give brief insights to some work we're doing developing algorithms for identifying at 3 scales, kind of the large scale, sites, cities, villages, at the intermediate scale of architectural features, and then at the smallest scale of artifacts themselves. So a little insights into the algorithms we've been working on. For those, all of these are going to be kind of focused on taking PyTorch frameworks and toolkits, merging them with remotely sensed data so that we can understand or detect archaeological sites and classify artifacts. So the first one is a case study coming out of South America in the highlands of Bolivia, Chile, and Peru. These sites are called chacus. They're essentially high altitude, very old game drive sites. So they're stone walls that people would use to funnel ungulates towards corrals where they could hunt or shear them. These sites you can see are pretty distinct. They're unreported though, so some colleagues came to me from my colleagues in anthropology to say, we have a couple of these sites that we know about. Can we use kind of machine learning to find a lot more of them? So what we did is we scraped a bunch of satellite imagery and trained a model that was really just trying to find sites or non-sites. We started with a relatively small sample size because that's all that we really had record of. And then through iterations of kind of trading and feeding the model and playing with some parameters, we eventually got was actually a pretty well-performing algorithm. And then when we cast it across a really large space, we got very high accuracy, I would say. One of the coolest outcomes from it, you'll kind of see the previously known locations once we kind of tasked the model after it had been performing really well. Doubled our sample size and have a much better understanding of kind of the archaeological features in that landscape, right? So we have a better understanding about economic and social boundaries just by using big data sets and machine learning. The other thing that I was most surprised on that this algorithm did really well is it was able to kind of handle a lot of different signatures, right? So it's picking up sites that are pretty easy to see and are very similar to the ones that we had before. And it's also picking up these very ephemeral signatures that are extraordinarily hard to detect. And it's doing that, again, with only a false positive rate of about 1.8%. So we're having to go through a lot of images on the back end, but it's still doing a lot better than archaeologists have done so far. The second case study I'm going to be talking about comes from the U.S. Southwest, the Four Corners region, where I do most of my field work. In this instance, what we're trying to do is task computers to find these large residential sites or these pueblo sites. What they look like from the ground, you'll see, is just a bunch of piled stones that might stand between 10 centimeters to a meter above the surface. But in kind of flattened imagery, we have this kind of muddied signature. Say if we look at USGS's LiDAR data, hillshade relief, you kind of get these signatures of these circular depressions, which are kivas, which are commonly associated with these residential structures. So we're scraping through a lot of the data and training it from with data sets from my partners at Mesa Verde National Park. So the only national park that's really dedicated to cultural resources, we can use that well-recorded record as a way to kind of train these algorithms and these models and then task them across the entire southwest to get a better understanding and close the kind of data gaps on where people were living thousands of years ago. This is a model that we just got some results from this week. Initial results are pretty promising. That was only a few associated directions and static imagery, and about 1,000 sites as kind of our training data set. We're actually getting pretty good performance at the 93 to 94% scales. We haven't tasked this across large areas, but for kind of smaller contiguous areas where we have good information, it seems to be performing quite well. The last kind of scale, I want to bring us down into the artifacts, right? The best case scenario is we could fly a drone, be able to identify new sites, and then at those sites, we could even then begin to find ceramics or artifacts that we use to then assign the dates of occupation to those sites. So if we could do all of that with many kind of multifunctioning algorithms at multiple scales, we now need to kind of train these algorithms to then be able to classify, not only like look at and find ceramics, but also classify them. So we're using a bunch of data that's been collected from our partners at Crow Canyon Archaeological Center, which is a nonprofit archaeological center outside of Mesa Verde. And we're tasking it to look at a very particular type of ceramics, which are called Northern San Juan whitewares. It's performing not as great because we don't have a whole lot of data, and there's many different classes. And the themes of how people painted these ceramics thousands of years ago are pretty similar. So it takes some time to learn and to train these models how to actually pick up this diagnostic signatures. But still, we're getting above an 80% in kind of the initial training rounds. And as we kind of get more of that data together, I'm hoping that we'll be able to perform something where we're going to be able to pick up sites, identify ceramics, all at kind of a 99% accuracy. So that's the ultimate goal. That's my 5 minutes. Thank you all and all our partners. Yeah. So actually, like training the model and having it, tasking it to then go through new data, that's pretty short timescales. We're not trying to iterate over, hundreds and hundreds of learning iterations, just because it's with such small training data sets, it's just memorizing that data, right? So we want to keep it flexible. And I also like to have kind of parity between site and non-sites, just because it does a little bit better as we kind of find new sites, we can plug those in. So it's tasking it over small areas. Once you kind of have initial training that is more than 0.75% accurate, then we task it to a small area, try to find some new sites, feed those back into another training iteration. So it's that long process that takes probably several months, just because you have to look at a lot of imagery and it's time consuming. But actually getting a model that then like eats through a bunch of images, that's hours and days. It's really not that long.
Pushback from any kind of colleagues that may not be familiar with the computer methods that you might be using, and maybe all we need is a compass and a string. We don't need.
Hell yeah. yeah. Throw your Indiana Jones hat on and go look at the dirt. No, I think it's important, right? So this is really, these toolkits are about building data sets that we can validate using traditional methods, right? So like when we find these new sites, quote unquote, find, that's a weighted term, but when we identify these new sites, it's not about treating that data set as absolute and a clear signature of past behavior. It's about giving us a better understanding of the likelihood or the potential of kind of the archaeological landscape we're dealing with, and then going out and doing some more traditional methods to kind of ground truth that data. So I see it more as kind of a partnership between kind of traditional methodologies and novel techniques. And you kind of, to do modern science well, you have to embrace those modern techniques without losing kind of the roots and the things that make archaeology fun, like getting to be outside. So yeah, there's pushback, but some of it's fair.
That has to be the last question, sorry. Now it's gonna be our second presenter. Managed to find her. Riley Knoedler, or Knoedler, better.
Hi, everyone. So I'm Riley Knoedler. I'm a data scientist at Western Ecosystems Technology, or WEST. I'm on our machine learning team. So today I'll be talking about a drone we've developed to do bat detection and monitoring. I'll talk about the drone a bit and also the AI we're using to process that data. This project is really born out of just a desire to have a more repeatable way to monitor bat populations, both in terms of abundance and species composition. This is work that started in 2020 when we snacked a bat acoustic recorder onto a DJI Matrice 200 and then also hung a microphone from it about 30 feet. And then it was also equipped with a thermal camera. So we can count bats through the thermal camera, hear bats with the microphone. And in 21 and 22, we conducted surveys at 18 field sites. Mostly had a lot of success with the methodology, but noticed that there were fewer calls from low frequency emitting bats than we expected. And we hypothesized that this was due to the sound of the drone itself interfering with our ability to pick up those bat calls. So last year, we partnered with Persimia LLC due to that issue and also with the need for an American-made drone to create a custom drone that was much quieter. So it produces noise in that 5 kilohertz range, which is outside the range of the bats we're trying to detect. And right now, we're doing more field surveys, test this new methodology, and test this drone, but overall really happy with how it's working. And so I'm on our data processing AI side of that. So I'll talk a little about the methods we're using. So this is a really hard computer vision problem because you can see this bat at the bottom of the screen, it flies across. It's really small, right? And nondescript. And so it's hard to teach a computer vision algorithm to find this. So what we're trying to do is we first use co-tracker, which is a meta algorithm to try and black out as much as possible of what's not moving by basically estimating how the background is moving and then assuming everything is stationary. And so when you violate that assumption, you get, and it's getting hard to see, but you get these white dots where the bats are flying. And you actually kind of get two. You get one where you think it's going to be if it's not moving, and where it actually is because it is moving. These transformed images, and found it performs better on the transformed images. So that's what you use for the first stage of object detection. And we track that, and it does decently well. So right now, and this is still in development, we're finding about 86% of the bats that are in the videos that humans could spot. But we're still getting false positives. So you can see it tracked that well, but it's also just tracking some random artifacts because the background subtraction isn't perfect. Now, luckily, most of these false positive tracks are in two categories. They're either like that red one on the top where they're just staying in the same place. They're just following some artifact of the transformation, or they're following something that's really just on the ground. And so the track is going to be more or less a straight line through the video. So the final step that we're still developing is then sorting out those false positive from true positive tracks. So we're experimenting, maybe using a time series classifier or maybe an image classifier, basically just to sort out the top, a false positive track versus the bottom, a real bat flying through. And then the step, we do still have human in the loop right now. So we have to send these clips to biologists for review and classification because there are birds and bats. And it's pretty difficult to tell the difference because they're so small. Birds tend to perch initially and then get flushed out, whereas the bats are always going to be flying and doing loop-de-loops. So we're hoping as we build our training set with the 18 new sites this year that we'll be able to distinguish between birds and bats with the tracks. And then, yeah, use these data to count bats to measure trends in species abundance and composition. So I can take a minute of questions, I think. Yeah. Yeah.
How many buildings?
So all this work has been done in the context of being near wind facilities because that's sort of West's focus area. So we haven't tried that. I don't know how it would, most of the areas we're flying, it's just like cropland or trees. So I don't know how it would work when you have a residential setting where maybe there's more going on in the background conditions. Yeah. So you should reach out to Mike. So Mike Geringer is the head of our drone program. I've never flown a drone. So, but I'm sure you would be interested. Okay. Yeah. 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 Yeah, great. Yeah, I'll give you my card after the talk. Yeah. Yeah.
One interesting hypothesis there about some of the drones suppressing the low frequencies. It seems something that would be easy to experimentally verify if you were to try to do that.
No, I have not. Maybe our drone team has. Yeah. Okay. Thanks.
Our next speaker is James Amato, and I'm sorry for the last name's pronunciations. It's hard, and he's from School of Energy, University of Wyoming. So thank you.
Hi, everybody. My name is James Amato. I work at the 3D Visualization Center at the School of Energy Resources. I oversee SCR's GIS and remote sensing capabilities. Starting at the Viz Center about a year ago, we decided to stand up a UAS program. One of the first hurdles that we needed to tackle was whether or not we needed to purchase an NDAA-compliant drone. This talk will give a brief overview of NDAA compliance and Blue UAS and share some things to consider if you're getting ready to stand up a UAS program. So the global leader in drone technologies is a Chinese-based company called DJI. DJI was founded in 2006, started selling their drones in North America in 2013. Their drones are highly intelligent and extremely affordable, but over the years have drawn concerns regarding national security. In 2020, the Department of Defense restricted purchase, or I'm sorry, in 2020, the Department of Defense was restricted from purchasing DJI drones, as well as other drone platforms coming out of countries like China, Russia, North Korea, and Iran as a result of the National Defense Authorization Act. Shortly after, some states followed suit, banning DJI drones for both state and local governments. This caused huge inconveniences to many local law enforcement agencies, as well as emergency services that had invested large sums into these platforms. Currently, the state of Wyoming restricts state agencies from purchasing Chinese drones. However, the University of Wyoming currently doesn't have any restrictions in place. And currently, there is a bill moving through Congress as we speak that is gaining traction and could result in a nationwide DJI ban. This bill was passed by the House on September 10th and is currently being reviewed by the Senate. So due to national security concerns from drones from foreign adversaries, the federal government initiated NDAA compliance and Blue UAS. NDAA compliant drones restrict key components from being manufactured in countries such as China, Russia, Iran, and North Korea. This includes everything from the components that make up the drone, controllers, radios, transmission devices, cameras, and more. For a drone to become NDAA compliant, the manufacturer must go through a formal certification process. Blue UAS certification refers to drones that are NDAA compliant but undergo further rigorous cybersecurity assessments. Most people in this room probably don't need a drone that's certified unless you're working with the Department of Defense. Some people in the room that's NDAA compliant if you're working with a state or federal agency. SCR decided to NDAA compliant drone. We work very closely with the Department of Energy and national laboratories. Our best interest in our UAS efforts. You'll also see something called Green UAS. Green UAS, similar to Blue UAS, certification comes from the International Drone Association versus a stamp of approval from the federal government. I would say consider yourself more or less on whether or not you need to be NDAA compliant. And some simple questions that may assist in help coming up with this determination, right? The drone, are you using it for commercial, for personal purposes? Is the drone intended for safety use? What are the implications of non-compliance? Also, how does it impact your budget, right? NDAA compliant drones are a lot more expensive than Chinese drones, right? But if you're about to purchase a Chinese drone, there might be federal laws in months to a year that restrict using these drones. So something to consider if you're getting ready to purchase a drone or stand up a program. So again, School of Energy Resource, we just purchased a Harris Aerial NDAA compliant drone. It'll be on display at the Expo later this afternoon. More than happy to answer if you have any questions, and stop by later on and say hi. Thanks.
If not, I forgot to give the gifts that we had for the presenter. And our next speaker is going to be Mike Killean, and he is the Deputy Director of University of Wyoming Advanced Research Computing Center. Thank you.
Well, hello. Got my timer here. So hey, I'm Mike. I'm with Advanced Research Computing, and I kind of want to hit two things from what I want to talk about today. And that is, there's a tremendous amount of effort that goes into supporting research as a whole, and there are groups like at every institution that are very passionate about giving the best level of service that we can. So as Dr. Chitness is opening, we have a vast infrastructure for the University of Wyoming that's pretty spectacular given the size of the university. We have a small team, 9 individuals that run this core, and our only job is to make sure that you researchers are able to do your work. Oops. So we offer a bunch of different services. We offer services to campus and to partners of our campus researchers. The biggest thing we do is which is our high performance compute cluster. We have about 350 nodes. We have a various number of H100s are our best, but the idea is that this service is open to all University of Wyoming researchers at pretty much no cost. And this acts as a stepping stone to move to larger national resources. So high performance computing clusters or supercomputers are thousands of nodes. Ours is 350, which is a medium-sized cluster, but you can start towards a higher end scalable platform. We also host 6 petabytes of storage, which, as everybody knows, big data is a huge thing. So hosting storage is paramount to success for researchers at institutions like ours. We have various flavors from high performance storage all the way down to low cost, publicly accessible storage. And it's a lot that goes into maintaining all of this. And so on top of that, our group of technical only people, you can tell by my speaking demeanor, I'm a computer guy. We also offer a lot of other things. We have groups, or there are groups like ours at all of our institutions. We do consultation. We will help with software development. We'll help with optimization of software, and we will help you use our services. And we'll even support use of those national resources. Our group is charged with doing trainings for use of these. We partner with other departments on campus, like the libraries. And then the coolest thing that we do that I'm excited to talk about is our specialized services. So if you guys use a high performance compute cluster, it only does one thing. It does high performance computing. You get on it, you use computational power. We've modified our infrastructure so that it is flexible. We can change our compute cluster from doing just HPC to doing specialized services like LLMs or AI workflows. And the ability to do this kind of changes the focus from what service do we have that you guys can use to what do you guys need us to do for you. And so we can modularize our compute equipment that the university has invested in, this large asset that you guys would be able to use, and make it tailored to the research that you need to do. One of these examples is a wild iris cluster. This is a traditional HPC cluster, but it's geared towards outreach to community college students. So any community college student from Wyoming can use our cluster to learn how to do data science, HPC, et cetera. And this is funded by INBRI. We also facilitate partnerships between academic institutions. So one of the things that is difficult for an academic institution, a research institution, or even for-profit industry when working with a government institution or academic institution is this partnership. There's identity management and all of these technical things that go into place that make it very difficult. My group makes this easy, we hope. And we also provide on-site support for researchers to use other institution supercompute clusters like Derecho or even cloud like Azure and GCP. And so the thing I would hope everybody takes from this is that at your institutions, there are groups of passionate technical people that are here to help, right? We're here to help you guys do the things that Dr. Burgess mentioned are kind of not the sexy part of the world of research. And that being said, this is how you can contact us. We will also have a table at the Industry Expo at 3:30. The thing I would kind of hope you guys take from this is what it takes to do services for research is complex, and we have a lot of services that we're here to support for you guys. I don't think I could say that any worse. That's it.
Thank you.
Yep, thank you.
I'll do the gift. We're running out of time, so if you guys want to ask questions to Mike, engage during the break. Now, Ramesh, Professor Ramesh is going to give us talk. Thank you for organizing this whole.
Okay. I got scared when you said we are out of time. I spent a lot of time. Good, good.
Considering 5 minutes, you can go.
Okay.
That's 5 minutes.
All right. So this project is all about, when I was in botany a long time ago, there was a professor who was also the department head. This is what he was studying. His job was to climb the trees and look for epiphytes that are growing on top of trees. So he asked me, because I'm doing remote sensing, can you help me with any remote sensing tools that we can use to study this? The picture he had in mind was that here is what that epiphyte looks like. We send it through a system, voila, something comes out saying, here is your target. Okay. So Dr. Brown asked this question a little more than 20 years ago, and we are still working on it. So the way we work this was, we have these epiphytes. These are the RGB images. To your left, we have to come up with what are called as training maps. We outline the feature or target we are interested in, and we need thousands of them to train these neural networks. So we split it into 70, 15, 15 for training, validation, and testing, and then put it in this black box, which starts to learn. And initially, you can see in the initial epochs, it's not good in learning or identifying the target. But as the number of epochs increase, that how many times it learns, it actually starts to recognize, yes, this is what you want me to find in this one. These are shown in the accuracy plot, which is very low in the beginning, and then it starts to increase, and then it flattens out. It's great. But when we started this project, we had only 100 plus images, not thousands that are usually used in these type of studies. Because one, these photos were taken in Costa Rica with a drone. That's the connection to this symposium. And second, when they were flying the drone, they will spot the plant and they will start flying towards that target. So we thought we had several thousands of images, but it turned out that since they were all acquired from the same angle, the algorithms didn't learn anything. So one thing would be that we want to move the drone around the target plant so we can get different perspectives. So the first step was we tried these 4 different algorithms to see which one can do a better prediction. So I'm going to skip through it because that's why. So we found the trans UNet, a variation of UNet, did perform relatively better. It was not there where we wanted it. So here is the RGB image with the training set. And this is what it predicted, saying this is where it thought the target plant was. So we came up with a new network, or what they do in this field is a modified network that focuses both on local and global features, and we were able to improve the predictions further. So if you see the column in the middle, this is the output from the trans unit. So if you see that yellow color or golden color, that means it's correctly predicting. And the red one means the plant was not there. And the green means something else got predicted as the target. So our network, which is the last column that you can see, you see less of red and green. That means it's improving better. So why a guy who's this old decided to start learning AI? The motivation behind it is this is the partnership we have through an institution in India. We signed an MOU with them. We do have 5 or 6 items for collaboration. One of it is faculty research and then mentoring students. So this is how the work got started. So here are the outcomes from that one. We do have publications. That's why I said I'm not elaborating. So all the details are in those papers. And we are able to mentor masters and now bachelor students. So we send them to conferences to present the work. So everything is one step at a time. And we worked right through the pandemic because it was all done remotely. So here are the next steps. Our next step is to include the targets where the drone was not close to it. So it's somewhere in the background. We want the algorithm to recognize that one. Second one is complex background, where there are other species that look like the target. So it's getting confused. So we want to work on that one. And the last one is there are other species of epiphytes that we haven't looked at. And where we are going now is that we want to include UW students to participate in this joint research, and we are expanding to include crop mapping and also going all the way up to satellite images. So I think that's my 5 minutes. And there is a poster that describes the work, and it'll be ready at 11:15. So you can get more details about this. We'll get started, and so we can stay on schedule. So while you are taking a few minutes to sit, I just want to briefly talk about the programs the School of Computing is offering. There is a table on the east side. We do have flyers that talks about the various certificate programs. So if you are a student, you are working full time, you would like to get a certificate, please stop by. We do offer them in many, and more programs are on its way. Masters, online, in person. So please take a moment to stop by the table, pick up the materials from School of Computing's academic program. So with that, now it's ready for us to listen to the next set of speakers. First, we will have Sergeant Travis from Pinedale, Wyoming.
Hey everybody, Sergeant Bingham, Minnesota County Sheriff's Office, Pinedale on the west side of the state, the very pretty side of the state, right? Our program started back October 2019, so we're up to 5 years. We had 2 pilots this year, I added 3 more, so we're up to 5. I'm just going to briefly touch on traffic crash reconstruction. That's one of the many things we do between barricaded suspects, crime scenes, you name it. Search and rescues, we have a big search and rescue division, we do a lot of that too. So Is it on this one?
Downward arrow.
Oh, maybe. Okay, so here's one of the ones we've done. Here to play. This is a really loose Pix 4D mapper. If it'll play. This is one of our first ones trying to get past can't get up and go back, trying to get some traffic crash data, some points on a. So this is just real raw data as we were starting out. Since then, we've added a lot of things, getting some grants. We do a lot of thermal with search and rescue, as you can see here. A lot of traffic crash stuff because in this day and age, public safety, we're all shorthanded, right? The troopers are no exception to that. We only have 2 left in our county right now, so doing their traffic crashes takes some hours to map out a crash where we can go out and do it in about 20 minutes and get them better data than they probably could. Just some examples of our program. Again, we started back in 2019. We've added thermal over the years indoor. We've been doing work with our local fire department for wildland fires. Right before our program started, we had a big forest fire where we could have done damage assessment if we had had this technology at the time where we were sending people in harm's way where there's no need to. We've had armed suspects and barricaded subjects in buildings and vehicles we've been using it on. Overwatch for public events and protests, things like that is invaluable as live data as much as it is data collection for us. So now, once we have our drone, there's a lot of, I guess I did dive into it a little bit more, but here's a lot of the software we've been using. There's a million of them out there. They're all really good proprietary software. But we've kind of stuck with Pix 4D when we're doing a lot of it in the fly. We have the ability to 3D model, but we have been doing a lot more in Pix 4D React as a 2D quick model for the troopers and for court cases. And then we do 3D fly-throughs for if it goes to trial. So there's some options out there. We do a lot of the autonomous flight, and we're mapping flight paths around a scene. And when we do some manual flight collection and video to get that better 3D clarity. So here's the video example. Play. This is one of our 3D models of a DUI crash. Play. There it goes. So this driver went off the road to the left here, jumped over the intersection of highways through a wide out power pole with a webcam on it. Right there. You can follow the tracks where she went. Slid all the way across the highway, never rolled, hit the bike path and landed right there. I don't know how she did that, but having that total fly through really helped on that conviction because she was trying to say that she hit the brake, she did this, she did that. We're able to prove on there there's no skid marks, no change until she turned. There's no change in speed, things like that. So this has really become popular with us as it is across the country. Some other associations we go to, like down in Texas, there's units that this is solely what they do is go around to traffic crashes and mapping these kind of things. Oh, did it just start over? There we go, sorry. Like I said, we do a lot of the 2D stuff, so here's a couple of examples. This one was a mapping of an op on a warrant on a house. So we were getting live footage of what it looks like now at the suspect's house before the team went in, that kind of thing. Up on the left actually was a pretty unfortunate case for us. We had a suspect fleeing that T-bone rammed into one of our patrol units and then continued to run, so we were able to map. On the far left, that point is where she struck her and had two wheels disabled and was able to go all the way down Main Street, all the way through that parking lot into a sign before we were able to stop and barricade her. But having all that data in her court case was huge too. But just having that overview shot ready for court and that system has been super beneficial to our county. Here's some more complicated ones. One up on the left, kid fell asleep on the way to school, went across all the lanes into the building, into the post office. And he was super lucky. There was a guardrail there. His vehicle went through the guardrail, went through the windshield right next to his head, and we were able to capture all that on a 3D model as well. This upper right one was a fatality head-on. Very complicated scene, marking a lot of points and data for them to be able to manipulate and move around and see exactly how that crash unfolded. This is another one this year. Kid stole the truck and was fleeing from us and had a big flatbed trailer on it, was unable to control it. Turned, too much weight, too much speed, went off and went through this building here. And right next to it was a home where the truck ended. He very clearly could have went through somebody's bedroom right there. Backing that out. This is one of the highway patrol vehicles. They actually asked us to come out now. It's faster for us to recreate this whole thing than while they're processing the scene. One is actually that fly through you saw. That's actually the overview 2D from the air. Anyway, that's a real basic down and dirty what we've been doing with it. Been very helpful. So yeah, you have any questions? Yeah.
What types of protocols do you have in place to like chain of evidence with these digital assets and if anything is possible? So how do you care?
So we have a external hard drive that we process all this on and produce PDF reports and outputs, and then it goes on to the shared secured the discovery drive between us and the county attorney, and then it goes to protocol from that, or shared with their attorney, etc. But it's all secured that way. For the troopers, the only way we've been able to found, unfortunately, to share is Google Drives because it's such a large amount of data between agencies. We don't have a good connect, so we're kind of secure it that way to them. But for court evidence, yep.
Thank you.
Paddington had signed up.
It sounds like the question is answered. Just curious about whether the crash reconstructions are visible as evidence in the
Yeah, they're actually very admissible. It's been challenged in a couple states, never in Wyoming, luckily. But it's actually the accuracy of those maps and those data is, millimeters of an inch. Every court so far has pulled that down when they've challenged it. It's been admissible every time. It's actually more accurate than a hand measurement. So, yeah.
For some of the images you were showing, the maps you had, like they were really nicely registered, kind of more local maps. As part of the data collection process, were you kind of taking ground control points on the ground, or is the GPS and the drone good enough?
So far, the GPS and the drone, we are trying to explore ground control points in that. We haven't got that far with our program yet, but we're trying to just get that. That'll just give us even better accuracy. But so far, we've been able to match it up. And those softwares have you can go from a satellite shot, and it's pretty accurate. Yeah.
One last question.
So my question is kind of two parts. Are you flying in your 107 or COA? And also, what's your how do you handle readiness to make sure that everything's updated?
That's a great question. So all our pilots in the new 3 stuff, we're all 107, just to be legit on that part. We use air data as a management for batteries, and we're always constantly rotating. We have my vehicle is actually built for that, has chargers and internet built into it. Drone package in the back to keep everything up to date. Batteries charged on the field, so we're never down. We have enough batteries that we're just constantly cycling through if need be.
I'll talk to you after.
Sure.
Okay.
Thank you.
For the speaker, thank you. And next, we have our own Ben Koger.
Great. Okay. Thank you.
So my name is Ben Koger. I'm an assistant professor at the University of Wyoming School of Computing in the Department of Zoology and Physiology. And I'm excited to be talking today about population monitoring of mobile salmon using drones and computer vision. So something that I strongly believe is that computer vision is able to transform our ability to understand and quantify the natural world. And one of the big drivers for this is our ability now, using a lot of these deep learning powered machine learning tools, to basically turn imagery into actual data, which is really exciting. And that's useful for a range of ecological applications. We already saw some cool examples. But one really big one is efficient wildlife monitoring. So often the starting point, whether we're talking about wildlife management or conservation, is just understanding how many animals are on a landscape and how does that change over space and time. But that's actually something that currently is still often pretty challenging. But a lot of these automated imaging tools provide some really exciting ways forward. And so what I want to talk about right now is thinking about applying some of these approaches in the context of Pacific salmon ecosystems, specifically up in the Bristol Bay area of Alaska. And so just to give you kind of a sense of the landscape, so a lot of these fish spend most of their life out in the ocean, but when they actually come back to build nests, reproduce, they come inland to a bunch of these little ponds. And so across Alaska, there are just vast numbers of these ponds, these landscapes. And so getting a sense of what's going on, kind of monitoring these landscapes is a really big challenge. Currently, for just a tiny subset, there are teams of humans who will walk across these ponds counting fish. And so what I'm really interested in is, can we instead think about using drones to more efficiently and more accurately monitor these landscapes. And to give you a sense of what I'm talking about here, so if we're flying these drones over these ponds, the big image there is just one of the raw images. And then if we look at a kind of a zoomed in view, hopefully you can start seeing these kind of red blobs, which are sockeye salmon. And aside the water is pretty clear, the fish are pretty big. And so it's not such a big challenge to train a pretty good machine learning model that can accurately, in most cases, pull out all the fish in these images. And so that's awesome. That's a great start. There's a lot of work that's already shown that we can do things like this. We can say that there are 8 fish here. And for any given image we have, we can basically count up the automated detections and say how many fish are in that image. And again, that's a nice start, but we're not actually really interested in how many fish are in images. What we actually care about is what's happening at the landscape level. How many fish are in ponds? How does that change again over space and time? And that's actually potentially a more challenging situation. So if we take one of the relatively smaller ponds in this area, we can fly the drone back and forth using kind of standard protocols, take a bunch of overlapping images. And you can see hopefully that we've fully kind of encompassed the pond in the imagery that we've taken. So any fish that's in this pond, we should have an image of it, which seems like a promising start. And as I said, we have models that can count all the fish in each of those images. And so if we wanted to, we could count all the fish in the ponds and all the fish in the images, and we can get some number. So in this case, we have 352 fish in these images. But hopefully, as maybe you've already realized, that number really doesn't actually mean very much. If we pick a given location in the pond, say a little peninsula, we have 12 different pictures of that same exact landscape point. And so say if there's a fish hanging out right next to that location, we've taken 12 pictures of it, counted it 12 times. And so big picture, what that means is that just kind of taking this number from a raw point of view is a giant overcount and really basically unrelated to what's actually going on in the landscape, which again is what we care about. So traditionally, the way that many people try to deal with this problem is by creating something called an orthomosaic, which is this. So basically taking all this overlapping imagery, stitching it together to create one sort of unified view of the environment. And so you can see now this peninsula that we had 12 images of it before, now we're back to having one. And so that seems awesome from this double counting point of view. But when we actually zoom in, it gets a little bit more complicated. So again, like we did before, we can look at one just kind of subsection. We can see a bunch of red blobs again, which are still salmon, so that seems awesome. But when we start trying to count how many fish are there, it's not obvious what we should actually do. In blue, I've highlighted kind of the clearest fish that look like how they looked in the imagery. But in white, I've highlighted all these cases that are basically blurry fish, what people call ghost fish in some cases. Basically, since we have lots of different images of the same area, and these fish are moving. So if a fish was in one part of the landscape in one image, a different part of the landscape in another image. Then the software, this happens to be Pix4D, basically will just kind of create a composite blurred representation. And it becomes really unobvious then what we should actually say about the number of fish in this area. If we just count kind of the clearest blue fish, then we have 10. If we count every possible ghost fish, we have 17. That's a pretty big range, and it's not at all obvious what, how we should interpret it. Something we can think about instead is we do have all this raw imagery of this exact location. So we could go back to that and say, at least at a specific moment in time, how many fish are in that landscape region. So we can look at that here, where again, so on the left, that's a raw image. We can look at the same region, detect fish again, and in this case, we can say, well, at least at that moment in time, there were 11 fish, which so it's cool that it's kind of within our range. At the same time, though, it's not actually 10, it's not actually 17. So we're kind of in a sticky situation. And this is kind of the current state of where things are at for this process. There was just a paper in 2024 that was trying to do reindeer counting using orthomosaics of moving reindeer. And they ran into the exact same situation. They're getting all these ghost reindeer. They were able to detect those ghosts, but they didn't really have a good way forward. Basically, just highlighting that we have this issue. So what we really need is just a new solution. Again, if we're looking at just the raw imagery, kind of uncorrected, we're creating giant overcounts. If we're looking at ortho images, we've got this kind of blurry mess. So we need more information. We need something different. And so the kind of way forward, as I see it, is not using this 2D information from the ortho, but actually looking at the real 3D information about the landscape paired with the actual location that the drone was every time it took an image. So those kind of dots up there are views of the raw images kind of projected into the landscape. And so what that allows us to do now is kind of move back and forth between the raw imagery, the kind of unified 2D view of the landscape, by being able to project these raw images into the actual coordinates of the system. And to kind of get a sense of what I mean by this, we can look at, say, a given raw image there, highlighted in red. We can say what was the actual location in 3D space that image came from. And then we can actually project that view into the 3D landscape. And so say for that given image, what was it actually recording in the scene? And that can happen for any given image that we care about. And so importantly, if we now do that across all images, then we can count for any location in the real world and say how many of our imagery, how much of our imagery. And you can see there's a huge range. In some cases, there's 14 images that are recording the same thing. In other cases, there are just a handful. But what this does is it gives us basically a normalization term. So we can detect fish in the raw imagery, project those detections into the 3D landscape, and then for that detection, ask how many other cameras were likely recording the same thing, which ultimately then allows us to go back to thinking about where actually are fish in the 2D space, similar to an ortho, but instead of it being sort of a blurry mess, now we have this nice way of actually going from detections to number of fish. So I think this might be blocked by the podium, but basically we're saying that there are about 46 fish in this map. And importantly, this is a sort of general approach. So I was showing a small pond. This is now a much bigger pond that can have over. And we can do this. So this is now over the course of 2 weeks. Every single day we can fly surveys across the pond, automatically detect all the fish in the raw imagery, and then kind of stitch them together so we can get these accurate counts at the pond level, but then also being able to actually locate fish within the landscape as well. So creating kind of a much more detailed view of what's going on in this landscape. So I don't have too much time today. All that I wanted to give you kind of a taste of that sort of general method. In fact, for this specific application where there's some interesting challenges with kind of glare and distortion at the edge of frames, like that, we actually built kind of a additional method that can also handle this in slightly different ways. I'm happy to talk about later. Importantly, using various methods, we can show that our range of methods do a very good job at the actual pond level, saying who fish are present in these landscapes. And ultimately, what that allows us to do is generate these ecological kind of data sets of how many fish are in these different ponds, again, across time, and also kind of spatially thinking about how does that distribution of fish change as well. I think what's exciting is allowing us this kind of new automated method for census examples that move, which previously, at least kind of in the orthomosaic context, wasn't easy to do. And then in closing, I want to sort of point out some future work that I'm excited about. That was relatively small ponds up in Alaska with fish. I'm starting to work with Wyoming Game and Fish to think about how can we kind of take the same approach, but scaling it up to really region-wide scale using aerial surveys for pronghorn. That's okay, kind of do the same idea, but at this scale. So in closing, I want to thank and acknowledge the great team of collaborators who were working on this salmon stuff, and with that, I'm happy to take any questions.
Yeah, go. Okay.
I just want to know how long this takes to do it. If you're looking at scenarios where you might want to do this very quickly to be able to respond to instantaneous fish distribution.
Yeah, so I would say once we have kind of, now we have the pipeline, we have good models, trained, things like that, then it could be quite quick. I mean, there's no reason that we couldn't fly the surveys in the morning and then kind of go back to camp and process them that evening. And
like in seconds or something. I'm thinking of like multi-messenger astronomy where you do this stuff so that you can detect something very quickly and potentially point on the telescope to look at it that might get more information. Do you have scenarios where it might be beneficial to have instantaneous information about moving animals?
I guess in the specific cases, not a need. And I mean, certainly you could imagine a case maybe where if you're trying to do sort of like real-time sort of like road crossing collision avoidance or something, where you want to very quickly be able to say like, oh, there's a bunch of deer like actively about to cross the road and we need to trigger something. I think that could definitely be an interesting case. Right now, we're doing this in the context, the sort of 3D mapping element is with Pix4D, it's one of these commercial softwares that doesn't make it easy to kind of do stuff really quickly. But I think there's definitely scope for doing that.
What are you finding the kind of acceptance level for this kind of research being at both the state and kind of like the Department of Ag, the Fish and Wildlife, or the National Fish and Wildlife for conducting it? Because I've talked with kind of some of the local people, and they are not really interested. They want to throw their guy up in a helicopter or airplane and do numbers, and I think it's a lot more economical.
Yeah, I mean, so what was interesting with the pronghorn case is that their team is very clear they do not want to be in airplanes anymore. They see it as just a giant safety risk and something that's not, just that if they could stop doing that tomorrow, they would happily stop tomorrow. So yeah, in their case, even if we were at the same sort of accuracy levels so currently what they do basically is they send their observers up in planes flying about 300 feet above the ground and count pronghorn as they go by, which I think gives them lots of valuable data, but definitely currently is pretty hard to validate because since you're not recording video, you can't really go back and see like how good was it.
And talking with those guys, that looks like 10. It might be 12, it might be 8. But
Yeah.
It looks like 10.
I my sense for them, because they're having to set quotas every year, there's a bunch of just stuff that has to happen. As long as they have data that they feel like they kind of understand where it's coming from and is kind of highly correlated enough with the information that they need, then that's good. And we feel hopeful that we can get to that with this kind of approach.
I have one question.
Yeah, I'm just wondering with the
point estimates, are you also able to generate any kind of confidence interval around your estimate, and what does that look like?
Yeah, that's a great question. That's something that we haven't gone too deeply into for this specific work, but is definitely something that's kind of on the, we'd like to do. I think there are sort of three core drivers of uncertainty, I guess, with this. One is just, in some cases, it's a little hard to see, but they're like trees overhanging stuff. And if we just can't, there's some just, are we actually observing all the individuals or not? Then there's how well can we actually detect the individuals in the raw imagery based on kind of how good our model is. And then there's kind of a final step of, is all of our kind of combining numbers together, is that actually working well? And so I think in some ways the easiest to quantify is just how good is our model. And what's nice in this context is the fish aren't super hard to see, and so our model's quite good. But I think there is some stuff that we'd like to do with, I think, sort of like bootstrapping based approaches of where, since we do have so much overlapping imagery, you could imagine creating these counts where each time you're only using, say, like 90% of the actual imagery. So you're always kind of getting slightly different mosaics and different patterns. And I think that could be an interesting way to generate some uncertainty kind of bounds.
Yeah, if you had good movement models, maybe you could do something with agent-based modeling too, where you're simulating taking different pictures of the pond.
Yeah, I think that would be super cool. There actually just was published some cool simulation work that was confirming, which is nice, sort of the assumption that if the camera is moving independently of the movement of the animals, then definitely you'll double count some and miss some in all imagery, but it's kind of neutrally biased, which is cool. So that's reassuring.
Thanks, Ben. I think we have two more speakers in the session, and I'm sure there will be some time to bring Ben and others back to answer those questions. So thank you. Next. We have another talk from law enforcement, Ethan from Laramie Police Department.
Thank you, guys. So I'm Officer Ethan Greenawalt with the Laramie Police Department here in town. It's going to be similar to Sublette County, oddly enough. We use ours a touch differently. I'm also on the special response team. That's our SWAT team here. So we'll carry ours with us because we got a bunch of rural area that we will use the drone if we need to check areas that we don't want to send people into. So we're just going to go over real quick our drone program, the technology we use. I got 2 cases in here that are done and finished, so there's not an issue there. And then when we can use it. Like I said, we got 2 drones. I lean more towards the DJI Mavic 2, just because it's smaller, easier to carry than the Phantom 4. As it was previously discussed, they may shut it down. If they do, we'll have to go a different route. But right now we got 4 107 certified pilots and the 2 drones. Again, that's usually the one that I gravitate towards just because of the size of it. The Phantom 4 is a bigger drone, bigger case, harder to carry around. We use it a bunch, aerial photography. A lot of times I'll get called out for finding runaway juveniles, especially if they have some mental health issue going on. They'll call us because it's easier just to try to figure out which way they went, where they went, if they're hiding, something along those lines. I just used it Tuesday to find a guy who ran from a crash over on Snowy Range. I don't know if you guys saw the cop cars over there. That was us. He got down in the river. I was a little late on that just because I had to pick up the drone, so we didn't find him with the drone, but cases like that, we use it. Since I'm on SRT, we'll use it for Overwatch. You'll see us at parades a lot. Jubilee days, we were down there, so we'll have it with us on that. Any sort of big public event, we'll usually be there. We're at football games, everything like that. So, and then, yeah, crime scenes are fairly easy to photograph. I think that's what everyone else here does. Just shoot it from the sky, go from there. I always take the originals, submit those straight to evidence, and then I can work with my rendition of the copies, so I'm not messing with the evidence that we need for trial. That stays in evidence. If defense wants to do that, that's on them. But my side of it, I'll make a copy of it and go that route, just in case I'm messing with any sort of PIX 4D or anything like that, that I'm changing something. This one here, this was earlier this year. It might be hard to see. There's a guy sitting right there. So what he did is he lit this valley on fire. He came around the front and he started a fire here. So I was able to hit the thermal on the DJI drone, pick up the fire signature on this side, and that's how we found him. He was a couple hundred yards away shooting towards us when we were coming in, but never hurt anyone of us or anything like that. So this one was super helpful with the drone, just because he's probably 200 or 300 feet above where we were. So trying to find him on this ledge right here was extremely difficult from the ground. So the drone was super helpful on that one. And again, like I said, this was all on fire. So when we had to come around, we came right through the fire around the back and to the front. That was the only way we could get up there safely. So also using it back here just to see where the fire line was and how it was burning was super helpful on that one. This was a crash out on 230, just west of town. It was a head-on hay truck, another semi hit. So the big thing on this one, they called fire out. You can see they were spraying all this. They actually ended up bringing a backhoe out. The thermal was helpful to be like, hey, your fire's more here instead of anywhere else on there. So they were able to clean all that up. You can kind of see where it was burning in this one. This is the same one as before, just a little bit easier to pick up where the fire's at. And then again, just an overview of it. Highway Patrol is super grateful when they call us because like Suffolk County said, it's accurate within a centimeter. Their GPS sticks are 10 feet, so the drones are way more accurate. We can get measurements of skid marks, whatever they need, way more accurately than they can, and it's faster. So, and then again, just another thermal overview. I'm not a huge fan of the DJI's thermal thing. It's hard to pick up people on this. And like I said, the first one with the guy on the hillside there was actually a cliffside, but the only reason I saw him was because of the fire he had beside him. He had a little small fire right beside him, and that's what I picked up. So, you guys got any questions for me?
Where does the pilot sit? Does he sit in a van with video and he's mic'd and talking relative to the other people in your crew? Or is it just whatever?
So it depends. Like that guy up on the cliffside, I was sitting right beside our commander because we were out. It was a SWAT call out basically. So I was sitting right beside the commander so he could watch. If it's in town, we can take our command van, hook a TV screen to it so they can watch it separately from what I'm doing. So we got a few different options, but
Just adapt, right?
yeah.
And just curious about, communications between jurisdictions, about your programs, right? So what works well for each and how often you guys communicate?
So each jurisdiction is different, right? Suffolk County, we don't work a whole bunch. They're just too far away. We work a lot with Cheyenne. So Laramie County, Cheyenne, we'll go train with those guys. On the SWAT side of things, they use their drone way more inside as to where our team's not big enough to do that. We can't have two people off the team and still do what we need to do. So ours is more like an overview of just we want people in there instead of the drone, right? We would much rather have, if something bad's going on, we'd much rather have you see us first than some sort of technology, right? So that's our thought on it. Like I said, Cheyenne's different, but everybody uses them just about the same.
So one question, just talking about jurisdictions, if a suspect is running and crossing the county line, what happens? Do you stop at Laramie?
It depends
line?
on the supervisor. So, right, we can continue. We got mutual aid agreements with surrounding jurisdictions, right?
Okay.
We can go into county, take care of that, go to next county, Colorado, whatever.
The last part of the TJ Amato days about 20 to 30 minutes.
Yeah.
How sufficient is that for session distribution?
It's not great, but we work with what we got. You're running right in there. We change batteries as soon as they start. We start losing that life longevity in them. So we'll swap batteries out. It's cheaper that way. But it's difficult because you think you see something, then you got to come back, change battery, and go back out. So hopefully that kind of answers your question.
Okay, thank you, Ethan. 1 second. We do these. Thank you for coming. So the next speaker has come from New Jersey. And I think this is a 20-minute presentation, just to make sure I am not watching. It's a 20-minute presentation.
All right. Good morning, everyone. I'm Hamid Jafarnejad Sani, assistant professor with the mechanical engineering department at the Stevens Institute of Technology in New Jersey. My research is in the area of controls and robotics. I'm going to get a little bit into the technical details of UAV research and autonomy aspects. So, research goal is to improve safety and security and resilience of autonomy in unmanned aerial vehicle, especially if you have a multi-UAV scenario, which some of the applications are emerging. So a lot of which we have heard a lot about. Also, second part is going to be more of drone that is going on in the field to improve the multi-UAV operations. So I'm going to talk about 3D site modeling. The other types, it's going to be important. And the second will be cooperations and improving the two aspects, one network and one right. So 3D site modeling, 2D images to reconstruct 3D digital model of the scene. Useful in many applications, including infrastructure inspection, mapping, disaster zone, 3D modeling, and construction, and a lot of military applications. And now we have built on the fly in some time-sensitive operations, for example, mapping a disaster zone to send the first responders and so on. And also there has been a lot of research going on in the area of integrating ML and AI into this 3D reconstruction, particularly neural renders, radiance fields for 3D synthesis that you use just a few images and fill in the gap using machine learning and AI to build a reasonable 3D scenes. And UAVs are particularly uniquely useful in capturing the images from the sort of different viewpoints, which are hard to access, and sometimes it could be hazardous or dangerous for a person to take pictures from those aspects. So, and they can take images from different altitude, which is also turns out to be very important for 3D model reconstruction. And we want these 3D models to be accurate, and we can build them very fast. One of the projects we have been recently involved with is that how we can sort of how many density of images do we need to create a 3D reasonable 3D models, right? So the research question was how many few images you can use from sparse images on the ground at different altitudes, and still be able to build a model of a sort of buildings, which is very useful for first responders, military applications, and disaster response. So we flew a drone platform, which is equipped with a GoPro camera on our campus, which is in New Jersey. Across the river is the Manhattan. imagine how difficult it is to get permissions to fly there. So on the left, you see the trajectory of the drone. So we had to numerous times land and fly the drone. So that's a lot of time consuming and sometimes tedious job to fly the drones and capture images, especially in this urban areas that there are a lot of obstacles in the field as well. Right? So on the right, you can see the 3D dense model from the code map, from the images we got from the library and the aesthetic field. So this gives us some motivation to see whether we can to somehow automate this data collection process, right? So we are in the business of robotics, so we want to automate everything. So we wanted to see if we can use machine learning, particularly reinforcement learning approaches, to determine the UAV next best views to be able to make a 3D sort of models with a reasonable accuracy and precision, while we have the drone on the air in a shorter time, or we can minimize the total flight time and distance, which is very useful for UAVs, which we know they have very limited flight time. So this is a simulation, so a lot of initial research ideas, we do it in the high fidelity and photorealistic simulation environments, because help us to just test the ideas before we get things on the field, right? So here, this is a sort of map of trajectory of the drone we generated using these reinforcement learning approaches, and compared against some uniform sampling. Every 5 meters or 10 meters, you can program the drone to capture images. So we want, and this table shows some of the results. We saw that with a shorter time, we are able to capture sort of images that eventually leads to the more accurate 3D reconstruction compared to the uniform sampling. And also at the same time, we could improve the 3D scanning quality in terms of PSNR, peak signal to noise ratio, and structural similarity index measure. And with that, we used some sort of training and tested on different simulation environments. So the second part of my talk essentially look into the multi-UAV missions and how we can improve the resilience and autonomy of this multi-UAV operations. So as you consider a UAV, so it's gonna interact with its environment. There are a lot of communication networks going on, especially if you have a multi-UAVs in the formation to sort of map a large area. And also there are interaction with the ground station, with the GPS, and also they use their onboard sensors like images to track objects for navigation, collision avoidance, and so on. So recently, if we want to apply them in a larger scale, we have to make sure that these autonomies are secure, especially with the given advances in the AI. There are different sort of possibilities or adversarial or malicious threats like denial of service, the deception attack, signal spoofing, jamming, adversarial image perturbation, that you can put a sticker on a sort of an object of interest and become invisible to object detection, right? So, so we look into these scenarios, particularly that a lot of multi-UAVs and multi-robot applications coming on board. There are some of them already being heavily used in warehouses, ground robots, for the plant tuning of multiple vehicles on the road, and also having drones in the sort of factory floor to scan and monitor, and also obviously the package delivery, which is another application which needs a lot of networking, and it's going to be in a very large scale. So here, and there are a lot of possibilities eavesdropping, replay attacks, and that literature have been pointing out that there are that could theoretically happen. Bias injection, denial of service, zero dynamics. So there are some active approaches, cybersecurity approaches to address that. From our point of view, we are looking at the dynamics and motion of the agents and UAVs themselves, and we're gonna detect anomalies when they operate outside their regular operation range. For example, if they are forming a V-shaped formation or line formation, usually we expect them to be in that normal operations. So we can formulate precise mathematical models, like a steady space representation showing here an input and output of our system, and contrast them against some predefined model of the operation for our system. And then also we can devise different type of possibility, injecting data into the network communications and try to see the effectiveness of our approach in terms of detecting and separating the sort of compromised drone or agent from the rest of the network to be able to save it. So that's part of the work we did. So we, for some simplified cases, we can find a precise mathematical set of proofs and also guarantees that when the sort of the system works in the sort of normal operation range and when it is not, and we can establish the residuals and find the thresholds to trigger the detection for our system. And we use some of these control theoretic approaches, like designing observers to span across the network, and we see these network topologies and changes in them, and we can model them, and then we can develop some approaches to detect any changes in the system. So obviously this is some of the research work that the applications are emerging, so we have to be on top of it. So before we test things in a larger scale, so we need to test them in a limited lab environment. So we have these multiple quadcopters that we can safely fly them in an indoor environment. So they're communicating with the different topologies, and then we try to inject different type of disturbances into the system, introduce and see if our observer detection is effective in terms of detecting which agent is out of its normal operation to isolate it from, to save the rest of the formation. In our case, we consider some of the challenging scenarios because if you have a sparse communication, you can show that you can have a space of operation or null spaces that you cannot easily observe. So it's not a trivial case that you can detect any anomalies even with some limited information you have. Usually you have a distributed system with many measurements, and they might not be sufficient enough to capture everything. So we look into that and see what theoretically is possible, what is not possible, and we test them out in these experimental settings. And another thing, which is again is used a lot in the self-driving cars and also to some degrees being applied to the drones, is using this object detection tracking, which you see them in a lot of applications. They're used for collision avoidance, decision-making, tracking targets, and so on. And also they have some application in the sort of multi-agent scenarios that, for example, in the sort of a multi-robot experiment with a ground robot and two sort of quadcopters, we're going to synchronize the motion just using the visual data, and we can do so without any other communication, similar just to seeing the scene and try to synchronize the motions. However, again, looking at the safety and security of these autonomous operations, recently with the rise of these generative AIs, for example, on the left, you can see that you can create a sticker putting on an object, and the detection software, the inference accuracy gonna decrease, right? So, or for example, if you have a bounding box, it's gonna be shifted away, or you can show that you can add a sort of a subtle image noise into the image stream and try to deviate the bounding box for the detection. For example, if you have a drone tracking a car, right, to move it to an arbitrary location, right? So we don't want to see these scenario. At least we're going to be aware of these possibilities, especially if you're using a black box type of machine learning approaches to do the detection, right? So part of our sort of research, again, focusing on identifying the vulnerabilities of this object detection cases in the sort of a dynamic scenario. So the computer vision community have done a lot of job on the static images, but we wanted to bring it into this type of dynamic scenarios that you have sort of moving, for example, a drone moving and tracking a sort of a moving target, right? So we used reinforcement learning actor-critic approach to generate this type of noises and add it to the video feed. And we wanted to see whether we can on the fly generate these noises. And most of these noises, they are very, is not perceptible with human eyes. So you can have a very limited noise added, but still sort of misguiding the object detection and your autonomous agent, but it's not very visible. So we are looking at some generative approaches to remove these noises and also filtering approaches to remove these noises from the images. And sort of that's ongoing research work. I would like to thank my students and also collaborators and our sponsors. Happy to take any questions.
What do you think the timeline's going to be where you're going to be able to use that swarm functions on the regulation side of things?
Yes, that's the ongoing work in the sort of package delivery. There have been some sort of companies like Bing and Zipline have been successful to get some approval to test some more remote areas, right? But to larger scale, like this package deliveries is still is ongoing process. And obviously in the military domain, they're already using those swarm formation control and testing these things in an experimental setting. I'm not sure how operational they are, but there are some really a lot of work going on in that area. So, but yeah, the regulation is a big challenge.
Thank you.
Yeah, thank you.